I'm going to show you how to get started with the RP2040. All the parts in this example are available from DigiKey. The RP2040 was released in January 2021 when Raspberry Pi released the Raspberry Pi Pico. The RP2040 is a dual-core ARM Cortex-M0, and the design has 6 primary parts: the RP2040 itself, the USB connection, the quad SPI flash, the clock or resonator, the 3.3 volt LDO, and the buttons that we need to change what mode it's in for loading and for reset. Now, I've used this particular design in a few different products and it works just fine. You notice that the RP2040 runs on 3.3 volts, but it also has a 1.1 volt bus. The RP2040 can generate its own 1.1 volt bus on pin 45. Notice that the reset pin has a 10 kilo ohm resistor for a pull-up. The USB-C connection is pretty straightforward. On our CC pins, we need to have a 5.1 kilo ohm resistor on each one to ground, and this tells smart power supplies that we want 5 volts. You also notice that it has 27 ohm resistors on the data line. These resistors need to be close to the RP2040 in your layout. I also add a Schottky barrier diode to make sure that voltage never backfeeds into your USB connection or your computer. The RP2040 uses quad SPI flash, which actually takes 6 pins. You notice that the chip select pin has a 10k ohm resistor pull-up, but it's also tied to the active load boot mode. When you press the boot mode button, it'll tie it to ground, which disables the quad SPI flash, and then when you reset it with the mode button held down, the RP2040 boots up without the quad SPI flash active, putting it in a loading mode. The RP2040 requires a 12 megahertz resonator, and in my example I have two 12 picofarad decoupling capacitors on the resonator. In order to get the 3.3 volts from the USB connection, I use a low dropout or LDO converter. Please like, follow, and subscribe for more electronic stuff.